For centuries, humanity searched the universe for another Earth. Thousands of planets have been discovered. Most turned out to be too hot, too cold, or completely uninhabitable. Then astronomers found a world unlike anything in our solar system. A planet that may hide a global ocean beneath a thick atmosphere. A planet that has become one of the most exciting candidates in the search for life beyond Earth. This is K2-18b. When astronomers first discovered K2-18b in 2015, they immediately realized they were looking at something unusual. Located approximately 124 light-years from Earth in the constellation Leo, the planet is neither a rocky world like Earth nor a gas giant like Jupiter. Instead, it belongs to a mysterious class of planets that appears to exist between the two. K2-18b is about 2.5 times larger than Earth and has more than 8 times our planet's mass. Despite its enormous size, it is not dense enough to be made entirely of rock. Something else lies beneath its atmosphere. Something scientists are still trying to understand. To explain planets like K2-18b, astronomers proposed an entirely new category. They called them Hycean worlds. The name combines two words, hydrogen and ocean. Unlike Earth, a Hycean planet may possess a deep global ocean covered by a thick hydrogen-rich atmosphere. Instead of continents and familiar coastlines, these worlds could be almost completely covered by water stretching across the entire planet. If such environments exist, they may offer stable conditions for life over billions of years. K2-18b quickly became the most famous candidate for this extraordinary new type of world. Like many of the most promising exoplanets, K2-18b does not orbit a star like our Sun. Instead, it circles a cool red dwarf known as K2-18. Because the star is much smaller and dimmer than the Sun, the planet can orbit surprisingly close while still receiving enough energy for liquid water to exist. This places K2-18b inside the habitable zone. But living near a red dwarf also brings danger. These stars are known for violent stellar flares capable of blasting nearby planets with powerful radiation. Whether K2-18b has survived that hostile environment remains one of the biggest unanswered questions. For years, the search for life beyond Earth focused on finding planets almost identical to our own. K2-18b challenged that assumption. Perhaps life does not require an Earth-sized world. Perhaps it does not even require an Earth-like atmosphere. If oceans exist beneath its hydrogen-rich skies, entirely different ecosystems could emerge, ecosystems unlike anything evolution has produced on our planet. The discovery of K2-18b forced scientists to ask a profound question. Have we been looking for life in the wrong places all along? And if the answer is yes, the universe may be far more alive than we ever imagined. For decades, astronomers could detect distant planets, but understanding what surrounded them was far more difficult. Their atmospheres were hidden behind unimaginable distances. Everything changed with the launch of the James Webb Space Telescope. Unlike previous observatories, James Webb can analyze tiny amounts of starlight that pass through a planet's atmosphere during a transit. Hidden inside that light are chemical fingerprints, subtle clues revealing what gases may surround an alien world. When scientists turned James Webb toward K2-18b, they were not simply studying another exoplanet. They were searching for signs that could reveal whether a distant world might actually be capable of supporting life. The first results immediately captured the attention of the scientific community. James Webb detected evidence of water vapor, methane, and carbon dioxide in the atmosphere of K2-18b. These molecules are not proof of life, but together they tell an extraordinary story. Water suggests that liquid environments may exist. Methane and carbon dioxide indicate a chemically active atmosphere. Combined with the planet's position inside the habitable zone, these discoveries strengthen the idea that K2-18b could be a Hycean world, a planet with a deep global ocean hidden beneath a hydrogen-rich atmosphere. For the first time, astronomers had found a world that matched this remarkable prediction. Then came a discovery that sparked headlines around the world. Scientists reported a possible signal of dimethyl sulfide, or DMS. On Earth, DMS is produced primarily by microscopic marine organisms. That immediately led to dramatic headlines claiming we might have found evidence of alien life. But science is rarely that simple. The signal was weak. The detection remains unconfirmed. And there are still many possible non-biological explanations. Today, no scientist can honestly claim that life has been found on K2-18b. But the possibility was intriguing enough to make this distant planet one of the most closely studied worlds beyond our solar system. Perhaps the most important lesson from K2-18b is not that we have discovered life. It is that we finally possess the technology to ask the question properly. Every new observation improves our understanding. Every spectrum reveals another piece of the puzzle. Future observations may confirm today's discoveries, or they may overturn them completely. That is how science advances, not through certainty, but through evidence. And at this moment, K2-18b stands at the very center of one of the most exciting scientific investigations of the 21st century. The answer may still be unknown, but for the first time, it feels within reach. For generations, scientists searched for planets that looked almost exactly like Earth. The assumption seemed obvious. If life exists elsewhere, it should probably evolve on a world much like our own. K2-18b challenged that idea. It is larger than Earth. Its atmosphere is completely different. Its surface, if it exists beneath the atmosphere, may be unlike anything in our solar system. Yet despite all of those differences, it remains one of the most promising places to search for life. Perhaps we have been asking the wrong question all along. Instead of searching for another Earth, maybe we should be searching for worlds capable of supporting life, even if they look nothing like home. James Webb has opened the door, but it is only the beginning. Future space telescopes will study K2-18b with even greater precision, searching for stronger atmospheric signals and confirming whether today's observations truly reveal a Hycean world. Scientists hope to identify additional molecules, improve atmospheric models, and better understand the planet's climate. Every new observation reduces uncertainty. Every new spectrum brings us one step closer to answering one of humanity's oldest questions. Not whether planets exist around other stars. We already know they do. But whether one of those planets is alive. Imagine receiving a message unlike any before. Not from another civilization. Not from a spacecraft. But from light itself. A tiny change in the spectrum of a distant planet. A combination of molecules that cannot easily be explained by geology or chemistry alone. That single discovery would become one of the greatest moments in human history. For the first time, we would know that life did not begin only once, that the universe found another way. Whether K2-18b becomes that world remains uncertain, but it has already transformed the search itself. For the first time, the possibility no longer feels like science fiction. Feels like science. Thousands of years ago, our ancestors searched the skies with nothing but their eyes. Today, we search distant worlds with mirrors larger than houses and instruments capable of reading the chemistry of planets hundreds of trillions of kilometers away. K2-18b is more than another discovery. It is proof that humanity has entered a new era of exploration. An era where we no longer ask whether other worlds exist. We ask what they are like, whether they have oceans, whether they have atmospheres, whether they have life. Somewhere beneath the clouds of K2-18b, the answer may already exist, waiting patiently for someone on Earth to finally discover it.